Okay, let's use this graph to answer some questions about limits. So we've got a whole lot of questions here, and these are all really good questions. So part A here, we're looking at -4. -4. So we're looking down here in this region. I only care about right around here, really close to -4. I don't care what's happening anyplace else. This says, well, what's the graph doing as we approach -4 from the left? That little negative there means you're coming from the left-hand side. So I'm coming up. What are my y values getting closer to? 0. Okay, what about from the right? I don't care about any of this stuff. Sometimes students get confused with all the other stuff going on. We're only looking really close to -4. What are my y values doing right here in this region? As I'm getting closer to -4, they're going down to 0. Both one-sided limits exist and are the same, so therefore the limit exists and is that number. That is the limit as x approaches -4 of f of x. This is a separate question. This isn't saying where is the function supposed to be. It says what's actually there. What is the actual y value when you actually get to -4? That happens to also be 0. We'll see later that that's the definition of continuity. If all of these answers are the same number, your function is continuous at that point. This function is continuous at -4. Okay, next, we're looking at -2. So I'm only looking right around here, like in this little region right there. As we approach -2 from the left, so I'm on this little chunk of the graph, just to the left of -2, what are my y values getting closer to? 3. What about from the right? That little plus means you're coming in from the right, so we're writing down here. What are my y values getting closer to? Still 3. Both one-sided limits exist. That means the limit exists. Well, let me rephrase that. Both one-sided limits exist and are the same. Therefore, the limit exists and is the same. So the limit, this question really is asking, if you were to fill in that hole, what would your y value be? That's really all the limit is. What y value is supposed to be there if this graph were nice and smooth. This question is asking what y value are we actually using at -2? We don't have a y value at -2. There's no solid dot anywhere. If I say had a solid dot right there, then this answer would be 6. Because that's where the solid dot is. I don't have one. So this guy does not exist. This function, we'll see later, will not be continuous at -2. To be continuous, all of these have to be the same number. Okay, let's look at the next one. We're looking at 1 from the left. That's not -1. This causes confusion sometimes. People see that negative and they start looking around -1. This says we're going toward 1 from the negative direction. So I'm only looking right in here in this little tiny window, right in here, right near 1. Don't care what's going on way over here or way up here. I'm really close to 1. As I'm approaching from the left, my y values are going up to 6. But as I approach from the right, what are my y values getting closer to? 3. In order for the limit to exist, both one-sided limits must exist and agree. This limit does not exist because we get different answers if we come from different directions. This question is saying, where's the solid dot? What is the y value of the solid dot above or below 1? And that's 6. This one could potentially be one of the answers we already have, or it may be something completely different. This does not have to agree with any of those. If, however, all of these agree, then the function's continuous there. Okay. Now we look at -3. Now, -3, as I'm coming in toward -3, the function's not approaching any single number. So technically, the limit doesn't exist. All the limits don't exist. We're going to write, obviously, we're going to write some negative infinities here, but just keep in mind that that's not a real limit. It's an abusive notation. So as we approach -3 from the left-hand side, so I'm riding along my graph here. This graph is going down toward -infinity. Same thing from the right. So we're going to write both of these as equals -infinity equals. Since those are the same, we'll say here this guy equals -infinity. It really doesn't equal anything. This is just a way of conveying information to somebody to just explain what the behavior of your graph is. It's not a true limit. And then f of 3, there is no y value. There's no solid dot anywhere above or below 3. That does not exist. Okay, let's look at this graph here. So as we mentioned before with infinite limits, this graph is going to have a vertical asymptote. You should remember that from college algebra and pre-calculus. We have a vertical asymptote at 2. And because we have an odd power, our graph is going to live up here on top. It actually has a horizontal asymptote here at y = 0 as well. And our graph's going to live up here in this section and down here in this section. And that's because we have an odd power. The limit as x goes to 2 from the left is -infinity. From the right, so now we're going toward 2, but from the right-hand side, we're going backwards up the graph. We're shooting up to +infinity. Now, technically, remember, with infinite limits, the limit really doesn't exist. We're going to still write something because this conveys some information. We still wouldn't say the limit exists in these cases, even though we're writing infinity. In this case, though, we can't even write that because we've got 2 different infinities. Like, in no sense at all does this limit exist. It just does not exist in any sense at all. So that's what we're going to say, does not exist. And that's a good place to stop.